Are you gonna tell me where you went? All the messages I sent with no reply. It's like that. You're just gonna walk into my room. I hate how you assume I'll take the pleasure and the pain, the sorrows in your brain, 'cause I know you're on the run. I'll take the pleasure and the pain, your secrets to my grave. Are you gonna tell me where you went? All the messages I sent with no reply. It's like that. You're just gonna walk into my room. I hate how you assume I'll take the pleasure and the pain, the sorrows in your brain, 'cause I know you're on the run. I'll take the pleasure and the pain, your secrets to my grave.
Yo, what's up? You can hear me, right? Hello, can anyone hear me? Can anyone hear me? Okay, let's start this this live. Okay, so let's run through the basics. So first of all, let's install the Arduino IDE. Let's talk a little bit about the Arduino IDE, and then let's start coding. We are actually going to I need to stop this echo. Okay, so we are actually going to play with LEDs. So as you can see, the title of this video is digital output. So basically we are going to make the Arduino do stuff for us. We are going to use it to control relays. We can control LEDs, which we are going to do. We are going to make a small traffic lights. Basically we are going to turn on and off some LEDs. We will see. Okay, so first of all, let's try installing the Arduino IDE. So to do that is very simple. Now, I encourage you to do this with me. Now, if your internet is strong enough, do this with me. It's going to be on your computer. You know, you don't need to have the Arduino with you to do what I'm going to do to show you. So if you have an internet, if you have a computer, just follow along. And if you have any type of questions, leave them in the comments. I will check as often as I can. Wait, there are a lot of comments. Wait. Yeah, let's talk English because I'm trying to make this channel English only. But hey, you need to, get used to English because if you are really, if you want to learn microcontrollers, you need English because all the informations that we are going to see is all written in English. So if your English is bad, believe me, bro, you're not going to go far. Nope, I'm not gonna speak Arabic, sorry. Hey, my English is not hard, right? You can understand it. And this is a good practice for you to learn your English, to improve your English, sorry. Okay, I absolutely have no idea how many people are watching the live, but let's just expect that someone is actually watching because it's gonna be weird if I'm the only one who watching live. Okay, so let's start. Okay, so first of all, let's install the Arduino IDE. So let's type Arduino IDE. Now the Arduino IDE is a shortcut for Arduino Integrated Development Environment. Integrated Development Environment. It's where you write your code, compile it, and you can send it to your Arduino boards. So basically you go under software, downloads, and here you can have a look at the Arduino IDE. Now the Arduino is multi-cross platform, meaning that it can work on Windows, macOS, and Linux. So depending on your operating system, download the appropriate one. So let's just type, let's click on installer or zip, it doesn't matter. And it's just going to run through the basics, like just keep clicking next, 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 and you are going to upload it. Okay, so let's assume you downloaded your Arduino IDE because I don't want to download it right now because my internet is bad already, and if I try to upload it, download it, sorry, the internet will crash, the stream will crash. Okay, so let's assume you downloaded your IDE. Now let's open the Arduino. This is the Arduino IDE, and let's have a look what's inside. Okay, so the Arduino IDE by default, it is going to open the last project that you did, and this is the automatic sterilization, the previous video which I did. Let's just make a new here, and this is like the default layout of the Arduino. Now here's the thing. Let's break it apart and try to understand what's here. Now this is the place that you will be writing your codes in it, okay? Now we have three sections. So we have the section before the void setup, we have this section inside of the void setup, and we have a section in the void loop. Now the void setup is where you make the initialization. Basically, let's say you want to control something. For example, you are going to send a signal from your Arduino to your LED. You need to make the initialization here in the void setup. And your loop, basically what you write here, we write stuff here. Basically we write stuff here, and every time, let's say the code will run, it's gonna reach the end, it is going to run again. So it's like a loop. Whatever you write here is going to execute forever. Is everything clear? How many people are watching the live? I cannot tell. Wait, we have 6 people watching. I hope they are paying attention. Okay, so if you have any type of questions, please ask. I'll try to make this as simple as possible, but yeah, maybe I will not talk about stuff that I think they are like obvious. But hey, if you have any type of problems, just let me know. Okay, so moving on, what we are going to do right now is we are going to turn on and off some LEDs. For that, we need our Arduino and our LEDs. Now, for that, we are going to use Tinkercad. Now, I made a video about Tinkercad previously and explained how to work with it, and it's really a nice program because you can actually use the Arduino without having an Arduino. It's a very powerful simulator. Okay, so now if you don't understand how this works, I'll try to leave the link in the description after I finish the stream, or you can just search on my videos where I talk about the Tinkercad as one of the best simulators of Arduinos, and it's free. We come here to circuits and we create a new circuit. Now I really like if people would just do they work on the same time, the setup and the loop? No, actually, first of all, the setup will work first because it is the initialization. Then the setup will not work. It's like one the pin number 1 to be an output, or pin number 13 to be an output. It's always going to be an output. But in the loop, it is going to repeat itself every time it reaches the end. So the setup is only read one time, and the loop, it is always going to repeat. And of course, the setup will be read before the loop. So we have the loop, we have the setup, we make our initialization, then we have the void loop. They're not run at the same time because we are using some sort of C and C++. Actually, it is called wiring programming language. I previously talked about in my Arduino tutorial. This type, it is like it reads line by line. It compiles everything, but for example, let's say it's like, let's say if you write something here and then write something here, it is going to execute the first command, then it is going to execute the second command. You will see. We are actually going to make. We are actually going to put this in our program to show you that the setup will always be read before the loop. Okay, so we have our simulator right here. So is everyone? Gray SJ, did I answer your question? Because I think I did, right? I want to know. I want to know, can I do functions with Arduino? Yes, yes, you can do, of course. We are going to talk about it. It's kind of a little bit advanced, so I'm gonna leave it like for another stream. Right now, we are just going to know the basics on how to turn on and off some LEDs. Then we can use functions, and yes, you can use functions. Okay, so let's make our circuits. Now, when you are working with microcontrollers, it is always good to have the schematics in your head, because you are not making a program that is going to execute on a computer. You are working with hardware, so you need to understand, for example, when we are going to turn on and off our LED, we need to know in which pin it is going to be. Now, because this is a rather simple example, we can just put it in any pin. But if you are working in a complex robots, then you need to know which pins are free, because you can have the same Arduino connecting to motors, motor drivers, servo motors, LEDs, and a lot of components. So for example, let's say I want to make it in pin 9 in my program, but the pin 9 is occupied by another hardware. So let's say I'm gonna put an LED right here. It's gonna be red. Now we need our Arduino, so we go to basics and we click on the Arduino. And here we have the Arduino. Actually, the cool thing about this Tinkercad is actually it has some built-in boards. Even the code is included. But let's just go for Arduino. Let's see all. Where is the Arduino? Let's say Uno. Where is the Uno? There it is. We go with the Uno. Come on. Wow. This internet. Okay, we have two Arduino. We don't need this one. Where is the okay, there is. Okay, come on. I need to throw it in the garbage. Oh man, how do I throw this in the garbage? Do I like click and delete it? Nope. Come on. Why is it? Oh man. Okay. Like normally you should just put it here and it should just delete itself. Why are they moving together? Okay, I don't understand. Okay, let's just pretend this one does not exist. Okay, let's just bury it here, and we only have this Arduino and this LED right here. Okay, let's make our connection. Okay, if you click on R, you can rotate it. Okay, this is better. So let's use the pin number 13 and connect it to the LED. Now there is something very important to know, is like it's not about coding, it's not about software, it is a relation between the software and the hardware. For example, we are going to make something messed up that a lot of people will do, and then we are going to correct. Okay, so let's just say I want to hook my my LED. Okay, the LED have a cathode and an anode. Cathode is always in the GND, and anode is always on the positive. Let's say I'm gonna put this here, and I need this to put it in GND. Now for those who does not understand, really doesn't know the Arduino, this is an Arduino board. Okay, this is the microcontroller inside of it. This is what does the magic, does everything, and all of these are just some hardware to make the communication between the software, the computer, and the user and the microcontroller easier. Okay, you can actually strip all this away and only use this as a standalone Arduino, and you can just upload the code to it, of course using another hardware, and this one will work without all of these. Let's see, is there some comments? Yep, that's a lot of Onos. Yeah, I can't really do anything about this. I mean, normally you should just grab it and put it here. Like, wait, now, yeah, you definitely should put it here and it should delete itself. But it does not want to for some unknown. Wait, nope. Why? Never mind. Let's ignore. Okay, so we have our LED. So we have the anode. Okay, let's change this to red, and this is, let's change it to black. So wait, black. Okay, so we have red as our positive and black as the negative. Okay, what's happening right now? Absolutely no idea. Okay, so if you have a look at the Arduino Uno, which is really the most popular one between the beginners. Why? Because it makes the connection easier. You see, we have these pins right here where you just connect hardware directly to it. I mean, if we had real Arduino and real LED, we can just plug it together, or we can use a breadboard and do the connection. Okay, here we have the pin names. We need this in the software. So basically what the Arduino company did, they actually printed the number of pins that have that are represent what's inside of the microcontroller. For example, we have pin 13. It's the pin 13 on the microcontroller, where of course the numbers that we are going to put in the hardware, they will get compiled and then they will change to hexabyte, so the microcontroller can understand them. But here's the thing. Let's say, okay, so let's run through the Arduino pins. So we have RX, TX. Now these are for serial communication. Basically, you can communicate between the Arduino and the computer, which hopefully we are going to make a video on this. We have the pin numbers, so it started from 2 to 13. These are what's called digital pins. We have A0 to A5, which are analog pins. We will talk about the difference between analog and digital when we start talking about analog. And we have V in, which is voltage in. We have GND, and GND, which is ground. And we have 5 volts, 3.3 volts. We have reset. Now, 5 volt and 3 volts, they are connected to the 3.3 regulator, and there is another 5 volt regulator, which is not here. This one is 3.3 and this one is 5. I think that's how it works. I forgot. Any questions? Refresh the goddamn page and redo it. Well, why? I mean, probably. Okay, you know what? Let's make it clear. Okay. Wait, if you move it, no, it doesn't want to. It doesn't want to get deleted. You know what? Let's just make a new one. Okay, circuits again. New circuits. Look at those Arduinos. Oh man. Okay, this time let's go to basics and let's just not basics. Arduinos, and let's just grab one that. Wait, do I click on? I should click and drag it, right? Wait. Where is it? Okay, there it is. Okay, so they include a resistor. Actually, let's try it without a resistor. And let's connect this. Okay, we have 4 views. Okay, worth my 30 minutes time. Okay, so let's start the coding. So keep in mind, so we have an LED that is connected to pin 13. Okay, now we get the Arduino IDE. So what we want to do is we want to make this goes on. Okay, so for that, okay, let's delete this. And okay, so first of all, we need to tell the Arduino that we have an LED. And well, the Arduino will not understand that we have an LED. It's just we know that if we put a signal on this LED, it's going to light up, right? So we only need the signal. We only need to tell the Arduino, hey, I want you to output a digital signal from pin number 13. It does not matter what's here. It can be relay, it can be a motor driver input, it can be an LED, it can be 10 LED. It does not matter as long as it's something related to this pin. and it is going to get activated when a signal comes to it. So what we want to do is we want to tell, hey, the Arduino, we have pin 13, I want you to configure it as a digital output. Now there is digital input where the signal goes inside the Arduino, and we have a digital output where the signal goes from the Arduino to the hardware. For example, this time we have the LED. So for that we use a command. Now here's the thing, you don't really have to memorize all the commands, but when you use them a lot, you are going to memorize. So we have pim mode. Now here's the thing, if you mistype it, for example, instead of capital M we put a small m, it's not going to get colored. It needs to change its color. So this time pin mode. Okay, pin mode, what we mean, we have pin number 13 and we want it to be a digital output. So we put the number of the pin. That's why I told you there are a lot of pins right here, and every time you want to use a pin, you need to know its number. So this time we put it in number 13. Now, because we want a digital output, we need to configure it as an output. For that, we just type output. And it's very simple. Now the Arduino knows that this is going to get configured as a digital output. Now in the loop, we just have to say the Arduino, hey, you have a digital output, do your job, and we want a signal on that pin. So what we say is we have pin mode right here, we have digital write. Digital write. Now what digital write is, it said we are going to write a digital signal on that pin. A digital, it can be either 1 or 0. And for that we are going to put 1, which is high. High in Arduino, it means 5 volts, okay? So are you following me, guys? This is not hard, right? Come on, don't tell me I'm doing a bad job as teacher. Okay, when you hook up, do you man have a step-by-step motor program? No, I don't have a step-by-step motor program. It depends on the type of motors you are using and the type of driver you are using. You just it's kind of easy actually to work with stepper motors. I mean, the driver will do most of the work for you. You just need to know how many rotation you want to do, and it depends on really on the type of motors you are running. Okay, so let's make this LED work. So we have a digital write right here, and we want to make this LED pop out work. So we have digital write, and we put the name of the pin. We have pin 13, and then we either can put high or low. We are going to put high here. It means that this LED is going to get high when we run this code. Now, how to run this code is quite easy. We just copy this. Of course, normally if you have an Arduino connected, you just make this. You can, of course, save it. We don't need to save it. It's going to run a verification to see if you have any mistype or any some sort of problems. Then you hit here, upload. Of course, after you check the port and you check the type of the Arduino you're using, you just click here and it's going to upload the code. But for this simulation, we just go to code, and instead of blocks, let's go text, and let's continue. Let's delete this because we don't need it, and let's paste our program. And what we do is we click down, start simulation. Yep, it's gonna make, so here we manage it to make our LED works, right? Now let's have a look at what's the problem. Now here's a problem that a lot of people ignore, which they say the current through the LED is 52 milliamps, while the recommended maximum is 20 milliamps. The unusable lifetime of the usable lifetime of the LED might be reduced. Basically, a lot of people will ignore what we say the voltage and the current limitations. basically what they are going to do is they are going to push more voltage, actually more current, through hardware and burn it. For example, let's say you have a phone. Okay, your phone, the charger will say, hey, charge the battery with 1 amps. You'll say, okay, I can make it 2 amps. You're gonna use a 2 amps charge. It's going to work, but your battery's life is going to die quicker. So we always need to pay attention to the current limitations. Now, if you remember, we actually had an LED right here, which I deleted. Now that LED, what it does, it limits the current. It makes it it drops the voltage, and then the current actually drops with it. So what we need here is we need to let's see. Okay, so the Arduino. Okay, wait a minute. Let's see. Where is, okay, code? Oh, there it is. Okay, let's go. All, and we need a resistor. Okay, so let's put a resistor right here and connect it here. Now, actually, there is a formula to calculate the value of the resistor that you want. Okay, let's see. Let's have a look at the comments. Just okay, so okay, let's see. Now we have resistor. Now the resistor, we need to change its value. For that, let's go from kilo ohms to ohms, and let's just put, let's say 20 ohms, and then let's start the simulation again. And as you can see, there is absolutely no problem, right? The problem just disappeared. Let's stop the simulation right here. Of course, if you want to know the formula of the resistor, it's just easy. You just Google it, which as I always do. Let's say how to calculate the resistance value of the LED for LED, and there you go. And you can actually have a formula, and I mean, sometimes you even find a calculator. You just put the type of the LED and voila. Here, okay, so basically you need to read this. Okay, if you want to learn stuff the right way, you need to learn. I might make a video about it because I think it's kind of interesting, because LEDs are everywhere, so it's very essential to understand how they work and how to work with them correctly so you will not burn them out. Great donation. No thanks, Mala Marwan. Okay, so okay, let's go to the code, and let's actually work here instead of the Arduino IDE. It's the same thing. It's this, actually now let's work on the same IDE, because here, as you can see, this one is colored, not colored, and this one is colored. Okay, so now we made the LED laid up, right? But this is boring. Let's make it blink. Okay, so for that we need to, as we put it on, we need to put it off, right? So we can copy this, go here, you can actually put it there, or just go here, and instead no, sorry, I mistype it. Let's go here, copy that, paste, and instead of low we put it high. So basically, if you want the Arduino to make something work, you put high, but if you wanted to make something goes off, you put it low. This is how it works. Okay, so now let's just copy this, and put it here. And what do you think will happen when I write this, when I compile? Okay, so tell me in the comments, what do you think will happen when I simulate this? What do you think will happen? Will it work? Will it not? Is it going to work? Is it going to blink? I don't know what the computer will give me, but I know what's gonna be in the real life. Okay, give it a shot. What do you think will happen when I start the simulation? Nothing. Yeah, I think probably nothing will happen on the computer. Wait. Does it light? Yeah, this is some of the problems between the real life and the simulation. Now, what we did right here is we made the Arduino make the LED on and off so fast that in real life experience you will not be able to see it, because the eye cannot catch very fast moving objects, meaning that you're not going to see anything. So what we need right here is we need a delay. A delay is basically is basically a shorter break. Basically, we tell the Arduino, hey, make this LED on, take a break, then make it off, and that break will be enough for our eyes to see it. Of course, don't make it too long, like you don't have to wait for hours. Let's just make it a second, okay? For that, we use a pre-built-in function called delay. Okay, delay, and we put the amount of milliseconds actually that the Arduino will wait. So we have 1000 milliseconds is equal to 1 second. Okay, now we need to copy this and paste it here. So what we did right here is we tell the Arduino, hey, I want you to turn this LED, actually this pin, which is connected to this LED, which is basically the same thing. We turn this LED on, we delay, wait for 1 second, then turn it off, then wait for another second, then turn it on again. Remember, this is a loop. It's gonna execute this, then this, then this, then this, then it is going to execute the first command again. Let's have a look at the comment. It lights. No, it does not. Yeah, Greystorm. Yeah, in real life, I mean, we are actually not, Marwan, we are not making it on and off at the same time. Remember, there are actually a delay between executions. I mean, microcontrollers are very fast, but this is a not real-time microcontroller, meaning that it is not going to put it on and off at the same time. It is going to make it on, but when it goes from this command to this command, it's going to be very fast, that it is going to light, then shut it down, light, shut it down too fast that your eye will not be able to view it. If you have a very fast camera and you just take photos of it, if you take photos of it, you will see that it is going to light up for just a small amount of time, then it is going to go off. Yeah, speed height. Yeah, what about height? It's not even microsecond. I think it's nanoseconds. It's gonna be. I mean, it's useless. I mean, that signal is. Yeah, it's really not practical for anything, really. So what we need to do is we need to put a delay. A delay is basically we tell the Arduino, hey, wait for few seconds or milliseconds. It depends on your needs. For example, if you are, for example, working with multiplex, for example, you have a lot of LED, you have a matrix and that kind of stuff. You want the delay to be small. If you have a temporization, for example, you walk in the house and you want the LED in the house to light up for, let's say, 1 hour, then go off. You can put, instead of 1 second, you can just put 3600, stuff like that. Okay, so is everything clear? Oh, nano, yeah, it's very fast. Microcontrollers are really fast, like really fast. Okay, so have a look at the simulation right now. So it's light for 1 second, it goes off, it come again in 1 second, it goes off. Okay, have a look at the time right here. So every second it's going to light, goes off, light, goes off, light, goes off. Now this is how to work with, I mean, this thing, for example, here we work it with LED. You can work with a lot of other stuff. For example, let's see what other components we have. Let's see. We have LEDs, we have light bulb. I think we have, okay, we have a buzzer. Yeah, for example, this is a buzzer. It makes sounds. Like, for example, instead of the LED, you can just, let's say, delete this, delete the LED, and just connect 1 to GND and 1 here, and you just start the simulation. Can you hear that? I'm not sure if you're hearing this. So did you hear that sound, that noise? It's like a bad speaker. I mean, with the same code you can do a lot of stuff. Okay, instead of a buzzer, let's see what we can use. We can use motors, but let's leave that for another video because we need to learn about stepper motor drivers before that. Okay, let's have a look what we have here. Actually, I think we don't have relays. Why? Someone put relays here, please. Oh man, we have relays. This is, wait a minute. This is relay. But how do you use this relay? Where's the data sheet of this thing? Oh man, I have to test this to actually know how it works. But you can use this code that we just wrote to control anything. For example, instead of the LED that we put here, if we put a motor that is connected to the motor drivers, we can control robots. We can just make it go. In the future, we are going to learn how to change the speed of the motor. We are going to learn how to use the digital input. So instead of just the signal going from the Arduino to LED or relay, we're just going to get the signal from other stuff. For example, a button or a keypad or something to the Arduino, and then from that command we can turn on and off some LEDs. But let's just say there is a question between which of these get executed first. I'm gonna show you that the setup will actually be executed first, and for that let's just say high. Okay, have a look at this. Just gonna put it high here. So we have a digital high. Then what we are going to do, let's say delay, and let's put like 2 seconds. Okay, 2 seconds here. Now what's gonna happen is this setup will work. So we're gonna have the put number 13, the pin number 13 as an output. We are going to make this this pin 13 light up for 2 seconds. Then we need to put it off. Let's just put it off. then it is going to start. Okay, let's put another 2 seconds right here. Then it is going to start this code. Okay, we need our LED. Where's the LED? Okay, let's put a resistor here. We need the LED, this LED. We connect it here, we connect it to pin 13, and from the ground. Okay, let's change. So this one, we need it to be black. This one is gonna be red. This one red. And of course, this is the anode. Anode always is connected to plus. We have the cathode, which is always connected to minus. And if we run the code, so it's gonna be for 2 seconds on, 2 seconds off, then it is going to start blinking. You see? Let's repeat this again. Okay, have a look at the time. So it's gonna be 2 seconds on, 2 seconds off, and then it is going to start blinking every seconds, meaning that the setup loop will actually execute before the void loop, which is very you know, what you'll expect. So this is how it should work, and this is how it works. Okay, I think we are done today. Yeah, I think we are done today. I think people are just got bored of my explanations and left. Come on, let's be honest. 2 people watching the live is not that bad. I mean, if we have 2 people, why I have 2K followers, meaning that if I want 100 people to watch my videos, let's stop the math. Let's stop the math. Math is scary. Okay, so yeah, I think we are done. Yep, we are done. Yeah, so if you like this video, put a thumbs up on it. We have 3 people who dislike this live. I don't know why some people would not like someone explaining how Arduino works. Anyway, I hope you I hope you like this video, and yeah, see you in the next one. Probably.
I guess you're back. Are you gonna tell me where you went? All the messages I sent with no reply. It's like that. You're just gonna walk into my room. I hate how you assume I'll take the pleasure and the pain, the sorrows in your brain, 'cause I know you're on the run. I'll take the pleasure and the pain, your secrets to my grave.